It's easier. Now, if I were, not working at the university, I was doing my own thing, I'm not sure which OS I would choose if I just got to choose one. And we're live. Okay, thanks. Um, but I definitely, depending on the topic I'm teaching, I definitely choose one OS over another. So right now, doing security stuff, I do Linux all the time because so much of what I'm trying to show, or vulnerabilities or hacks, start with command line stuff and show them how to actually be compromising. And then we talk about mitigations and countermeasures and things like that. Which I do have to tell a funny story on one of my students. I told him I'm going to tell the story forever now. So I just got done the same thing I did with you guys last week in a very condensed. We had a big long lecture on injection attacks, and I went through and we talked about those and showed some of them. And then I ran out of time before I could get to countermeasures and mitigation. So on one part of me says, okay, you just taught a room how to do something bad and you didn't tell them why they shouldn't. This is probably not going to go over well. So I told him, I said, okay, over the weekend, this happened yesterday. I said, over the weekend, do not go out and just experiment to see what websites are injection vulnerable. I said, that would be called illegal, and I want you back here in class on Monday, right? So don't do that. I said, and then I just flippantly said, it's not like, don't go out to like the NSA and try this or something like that. They're all working on virtual machines. I've given them external drives. They have their own sandbox, so they're all self-contained. I said, if you want to experiment on the things that I'm showing you, it has to be in this sandbox. Stay in your sandbox. To which then I had a student, serious, ask this question. So if I'm on the VM, then I'm in the sandbox. Could I then go to NSA from the VM? I'm like, oh my God. That's right, I'm being recorded. No, you should not do that. But it was just just the fact that didn't really really didn't understand what I meant by staying in the sandbox, obviously. And no, you shouldn't be trying to attack the NSA from any platform at all, ever. It's just sort of a common thing. All right, so last week, for those that are here, we went through and looked at the #1 vulnerability from web attacks called an injection. It's not just web. And I'm teaching a class right now where we look at every single one of these vulnerabilities. And it's in a course called Secure Software. And it's about coding securely. And we have to start thinking about how you code secure. It needs to be proactive, not reactionary. You shouldn't always wait till the software is done to look for vulnerabilities. You need to be doing it early on. You need to do it clear back at the requirements before a single line of code has been written. You should be considering security at that point. Okay, so that's the soapbox, right? So last week we looked at doing SQL injections and showed how we could do it. It was very simple. A 4-year-old can do it. And so what I wanted to do is I wanted to bring that back to the table today and say, you know what? It's more than just SQL injection. Injection doesn't necessarily just mean a database injection. The injection attack in general, to make this more general, is that we're talking about somehow using malicious or malformed inputs and actually having them run through some interpreter to be executed. Now in the SQL, it meant that we were dropping in SQL code into a form, and all of a sudden, voila, we were in as admin because we were able to manipulate the SQL statement. Well, here's another example. Now, I know you guys aren't doing Java here, but it's pretty simple Java code. Let's just look at it real quickly. The top is a simple class. The scenario is, let's say it's some sort of a credit card matching program, right? And so somehow this code is embedded somewhere where someone goes to pay, and to do that they have to enter in credit card, month, day, year, and it matches what's already in the system. All right, that's the scenario. All right, I've really oversimplified this. All right, so the top class creates what's called a Gregorian calendar, which is in Java. It's one of the classes out there. And notice that's not actual code that says unknown to you. I'm saying I actually have it coded and I have a date right now. We're going to run it unknown to you. You don't know what that date is, but you're going to be able to figure it out using an injection attack. All right, and that's what I want to demonstrate for you. So let's say they enter some stuff, and let's say it doesn't match the date. Well, then if you look at the system.out.printf statement, and every language has variety of tools. In Java, you have a format, you have a printf, where, in fact, in C# you have something similar, right? Where you give it a string with some format specifiers, and then you give it the data, and it drops it into the string of formats, right? What is that? What is it? What is it? Standard format? Oh, string format. Right? So something like that, right? So what this would do is this would print out the arg0 would mean the command line arguments, what's being sent in. It would print that out and then say that didn't match. Hint, it was issued on, and that %1 $te is going to actually say what the day of the month is. So it's going to give a little hint like, oh, that didn't match. It's sort of like saying it's the card that was issued on the 5th of a month, trying to help the user a little bit, right? Okay, so let's run this. I have this up here above. So if I come along and run this this code, and I just, let's say I give it a date. Let's say I give it, I don't know, 5/8/2018. It's going to come back and say 5/8/2018 didn't match. Hint, it was issued on the 23rd of some month. So it's trying to help me, give me a little hint. Well, where did this 5/8/2018 come from? Well, in the code, it's the arg0. It's the command line arguments that I sent into this program. That means whatever's coming in as a command line argument, I am blindly assuming is good, and I'm going to put it into the Java interpreter to be interpreted. That, ladies and gentlemen, is unsecure. Right? I'm just taking it and assuming that's okay. Well, what if I did this? Let's run it again. This time, instead of send in a date, I'll send in Bob. Bob did not match. Hint, it was issued on 23rd of the month. Oh. Well, what if I now do this? %TM. That's a string, isn't it? But what is %TM? And I gave it to you in the comments. It's actually a format specifier. And so what's going to happen is that data is going to come into this program, and instead of just blindly being seen as a string, you're going to put %TM into the printf statement. Immediately, that becomes a format specifier, and now it's looking for data. It works beautifully. 05 didn't match. Issued on the 23rd of some month. Anybody want to guess what month? May. You didn't know the date. I've not shown you the code at all. This is a compiled program. You don't even have the source code. And you were just able to inject a format specifier as a command line argument, and we're able to get hidden data from it. So obviously I can do it again. If it works with month, it's going to work with year. 2017 is the year. So 5/23/2017 is when this, quote, credit card's date would have been. And yet, you didn't know any of that when we began. You still haven't seen the actual code to see the date set, right? That is unsecured. And that's at the heart of what an injection attack is. Just as an SQL, every language out there has unsecure methods or functions that if you take user input and just blindly put it into those functions, you're taking whatever they give you and interpreting it, which means you're trying to execute that. You never, ever, ever want to do that. So if we take a look at, let's change this code. So let's go vi cc match.java. Okay, so there's the actual code. You can see I started a Gregorian calendar, 2017, May 23rd. I want to change this now. I'm going to change this instead of the arguments. Forgot I was in vi. Insert mode. Okay, so now what I want to do is I'm going to put a %s, and what that will do is it will be a string. So now it's not going to interpret the command line argument. It literally is just going to take it and regurgitate it back out to the screen. So there's no interpretation, no execution of it. So let's get this right. That doesn't match, hint, blah, 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 blah. And so then I have to, so now I have a %s formatter, format specifier, and I have the %te. So I need the data going into that first one as my args sub 0, comma, and then the calendar object goes in as the second from that. All right, so let's compile this. Shift CZ, save it, compile Java C, cc match.java. Okay, good. So now let's run it again. So now let's come up here. cc mat, we'll do it, try it again with 5828. Oh, look at that. I just shot myself in the foot. That's right. Still ran enough for us to see before it blew up, right? I'm not going to take time to fix it. If I ran it again and I put in Bob did not match, right? And so now the real test is if I tried to put in that format specifier, we'll use %tm to get the month. %tm did not match. I took it in as a blank, as a string. I didn't interpret it. I didn't try to execute it. That is now secure. Before it's not secure because now I can give it malform. So the entire thing about an injection attack isn't always SQL injection. You can do an injection attack at the command line level. You can do an injection attack in JSON. You can do an injection attack anywhere you take user input or inputs from some external system. It's the end of the, I mean, that's what it's all about. That's why it is the #1 vulnerability out there. So you have to sanitize those things. And that's what I did here. I sanitized it by treating it as a string, not as something that I'm going to actually throw into a function and have a function actually execute it. Does that make sense? Yes?
So you're attacking on the back end. Would it be worthwhile to validate the input so that you only expect, so instead of a format specifier, you only accept certain inputs?
Sure, absolutely, and that's a good thing. And like in a web app type of situation, putting some JavaScript on the front end to do some validation and stuff is great. That will keep out the ethical people, right? Because once it starts being passed off, if I can get to the server, it doesn't matter what you did on the front end. But at least it will prevent a good majority, right? So it will prevent the script kiddies, things like that, from trying to do a SQL at a login. Great, we're done with that. but you still need to find other ways to solve it on the back end. Yes, sir.
Shouldn't, speaking of libraries, shouldn't the most popular library in the world right now be a syntax checking / sanitizing / bulletproofing library for all input?
Absolutely. You think it's going to be secure?
Well, the open source idea of a lot of the right eyes on it, if a lot of the right eyes do
Yeah.
about it.
I agree. I totally agree with you to have some sort of a black box out there that we could use to throw everything through. But now you got to trust the black box, and we've tried to make many black boxes in the future or in the past. There's tons of things out there like that. They're just Swiss cheese. I mean, just full of holes. So I don't know that it can be done. It'd be great. I think the open source arena has some good possibilities, right? Because he's right, because everything is open. We're going to show everything. We're all transparent about what we're doing. Yes.
So in the original unsecured code, you were just so the arg 0 could have been any variable type. It could have been a string, but also could be that specifier.
Well, it is going to be a string because in Java, on here you can see in public static void main, string brackets args, that's an array of string is the command line argument. So it's coming in as a string. The difference in the two code, in the top code, I'm going to take the string and actually interpret it. I'm going to put it into a function where it's actually interpreted versus it is regurgitated. It's just a string. I'm not going to do anything with it. I'm just going to take it and do maybe comparisons or things like that. So in the first one, I'm actually trying to theoretically execute it by throwing it through the printf statement. That's the problem.
So I've been sanitizing my user input strings, but I have not
Keep talking. I got to get to the next one.
I have not been doing that with my user input, and I'm in C#, so it's strong.
Okay.
Not been doing that with, say, integer inputs. Is that correct? On the assumption that you can't inject if it can only be integer.
Right. Yeah. If you're right.
Is
If
this
it's
limited to string inputs?
yeah, string inputs are the danger. Absolutely, because if it's strongly typed, and you know what it's going to do if you throw a non-typed thing to it, whether it's going to throw an exception or whatever, then you already have that. They're not going to be able to. You're not going to execute anything on that. So you're right. Strings are dangerous. At the end of the day, strings are horrible. We should never have strings. Should always work in numbers. All right. So that's the first one. The next, that's the follow-up to last week. Now I have 30 minutes to do this week. The next one I want to look at is what's called insecure direct object reference is the title. And basically what it means is, are you making reference somehow, maybe web specifically, to some file that you're making a reference to an object file in an unsecure way so that someone could possibly make some changes to that. Great example. And I don't have this one as an example, but this actually was, I think Nokia. I think this was a problem out on Nokia's site once. There was in their tech support site, if you had a problem, by the way, Nokia used to be a phone company. Anyway, I think they still are, aren't they? Oh yeah, look, somebody's got one. Yay! Anyway, they used to have this tech support site where if you had a problem, you could submit a ticket. It's a ticketing system, right? You submit a trouble ticket, etc. And then you had a login to that ticketing system. Well, what they ended up doing was the tickets were numeric, right? I mean, they're going to be numeric value, and they were incremental, right? So you're at ticket 1,000, the next ticket ends at 1,001, etc., etc. And in the URL, when you logged in, was all their paths, and then they had ticket as a parameter, ticket and your ticket number. You could change the ticket number and you immediately got to see the other tickets. Right? They were using that ticket. Yeah, isn't that nice? So you could sit there and go, okay, I'm at ticket 10,005. Well, I'm going to guess the first 10 tickets are probably testing tickets from somebody in the developer group. So let's go look at ticket 1, 2, 3, 4, right? And then immediately I can gather information on that user. Really bad, right? In other words, they didn't tokenize it. It needed to be tokenized, so you were given some sort of a random number that associated with your ticket, and so you couldn't necessarily guess others or be able to use it that way. Same thing here. Here's an example. So what I have shown you on this is actually a web request, what you're seeing here in the middle of the page, where we're looking for, if you read down, you'll see in red, we're going to actually, we want to go see this text file. Here is the website. This website, by the way, you can build this yourself if you're ever interested. At OWASP, they have a thing called Matillidae. It's what they developed for pen testing, penetration testing. And so it's unsecure on purpose so that you can demonstrate and you can work on fixing, etc. And so this is where this comes from. Now what I'm going to do is I'm going to use, sorry everybody, I didn't know what to do. If you're online, hang tight, go get a cup of coffee. So if you have a web browser, I'm sorry guys for those online, I don't know what to do. And then a proxy, and then your server. Why would you use a proxy? Why would you ever use a web proxy? Anybody know? Anybody know what a proxy is? Start there. We've got a few head nods. Okay. Yes.
It's basically like an intermediary server that handles your traffic, but there's like an extra point between.
It is. And oh, go ahead.
The web browser, depending on who it's being used by, the web browser may want to hide who he is, his IP address, and other information.
Good.
And the proxy could be used, but it could be used from the other way around. It could be a proxy that's used behind the servers behind it.
Right. And corporations, a lot of times will put up a proxy server, which allows them to control their web traffic. Right. So you probably have acceptable use policies as for what is appropriate web browsing, things like that. And they can sort of handle that through the proxy. But the other thing is for speed. Let's say, and I gave this example in my class, let's say, you know, at my university, they have an assignment. All computer science students have to go out and read, you know, Coding 101 by XYZ, right? And it's an online article. They all go back to the dorms, and now you have 100+ people all trying to go to that same server. A proxy, if we put a proxy on the inside of George Fox, right? So inside George Fox, we have a really, really big pipe, and it's screaming fast if you stay inside. And the second you go outside, that throttles down a little bit because now we have leased lines and things like that. Well, you don't want all that massive traffic trying to shove through the small pipe. So a proxy can benefit you because the first person out, the proxy sees it and says, oh yeah, I don't even know what that is. As it comes back, I grab a copy. The next 100 people that hit that in the next 2 minutes, oh, I already have that. Here it is. And I don't send you to the server. And so all of a sudden, I've taken all that traffic down to one, right, for efficiency. It's very, very, very powerful. Now, what we're going to do, what I'm going to demonstrate, I have a proxy on here, and I'm putting all my browser traffic through this. Now, by the way, I'm totally self-contained. I'm not going anywhere out on the internet. I'm self-contained in here. And I'm going to capture the web request for this, which is what I've given you here. And then we're going to manipulate it, and we're going to send it on to the server. So we're going to sort of man in the middle this just a little bit so you can sort of see how this could work. So if I come to, we're doing A4, insecure direct object reference. Let's go to, I think it's books. Oh, text file viewer. All right. Intercept is off. So here's this. It says all sorts of books. I can see Intrusion Detection in Computers by Victor Marshall, Overview of ATMs and Information, yada, yada, yada. Hacking 101 by Johnny Rotten, etc. Right? These are all, just say, text files. Say I want to see this one. Now, how it should work is I can click on one of these. I hit View File. It hits the server, and it pulls back that text file. Everybody see that's the functionality. That's the use case. Now let's look at a misuse case. What if I intercept that traffic? So let's say, I'm going to turn my interceptor on. I come back and say I want to view that file. Here is, I know it's hard to see up here, that's why I printed on your paper. Here is that file. It's the web request. Oh good, it put it in red. Nice. So this thing in red is what's being requested. Well, notice that it is a reference to an actual text file. Now it happens to be to some URL. I wonder if I could get to a local file. And if I can get to a local file, I wonder if I can backtrack through the file directory and get to a system file. I know everybody in the room's like, I would never think to do that. That would be correct. Don't try that. But as an example, I'm like, well, I wonder how this thing works. So what if I'm going to replace this with, I'll do .. // foo. I'm guaranteed there's not going to be a file called foo on this server. But how does it handle the directory traversal? How does this thing handle it? Okay, so to do that, okay, this is where I have to quickly put in here .. / foo, and I'm encoding this. This is a very cool tool, by the way. It's called Burp Suite, and it's free, and you can use it to do lots of nefarious things, although you should do it for research only. Always self-contained in a sandbox, right? All these things. So I have to encode this. You've seen URL. Oh, yeah, I know that. I'm on a Mac. Okay. You've seen URLs like this. Like look at what's in red, where you've seen like the %2 and the %2F3A, right? Where spaces and things like that get encoded in text. In order to do this, I need to encode all of it. And so I've just done that. I'm going to drop in that encoding that I just showed you. So now I'm going to drop that in. I'm going to forward this onto the server now. Oh, thanks. Thank you. Okay. Forward that on. It comes back. Now, I can sit here and actually look at the HTML that's coming back, but I'm just going to forward whatever came back to my browser, and let's go look at it. What happened in the browser? All of a sudden in the browser, it aired out. But boy, did I get some information. It may have aired out, but I have a real hard path now. I know the path that this is using for its web root. I own this thing now, right? I mean, so I can look at that and go, well, okay, well let's see about how about backing up and getting into the etc directory in Linux and looking at what is the actual configuration file for the web, right? For Apache. Let's try it, right? So again, I want to view this text file, capture the packet, and now again, I'm going to substitute in. I need to go back over to my decoder. And I'm going to go /////////////// httpd.conf, which is the configuration file for the web daemon, which is what web servers use when they start up. So I'm going to copy that, come back over, drop that in, and go ahead and forward it off to the server. And it already came back. Let me go ahead and push it out to the browser. And here's my browser with a problem. What did I do? Oh, Kong, what is that? Okay, fat finger. Sorry. Hate it when a plan doesn't come together. Decoder. Conf, like configuration. App. Yes. Oh my gosh. Thank you. I was hurrying. Yeah, I need to get into the Etsy directory. There we go. Backup to, go into the Etsy. All right. I don't want that. I want this. Well, now you know what's going to happen. How anticlimactic is that? Golly. All right. So go to my browser. Ask for the file again. Capture the request, the web request. Paste in this new thing. Forward it to the server. Comes back. Forward it to my browser. And here is the configuration file for this web server. I don't even have I don't have privilege to that. Right? So all of a sudden, because the initial code of a drop down and you choose a text, you choose which book you want, and then the code is written to go and actually hard code request that particular the request itself has that URL in it directly to that reference. Well, then I can start to play with that and see, can I do other things. Now some of them might think, well, wait a minute, if somebody's doing this and you're in the middle and you grab it, it's already going to go and come back. That's true, but if I grab it, I can get a copy of it and I can keep trying with that. I can take that and then send it off. I can change some of the headers so it comes back to me. I got a copy of a valid request. I can sit here and play with that. And so until I can get what I need. So that's an example. Not real good. So how do we solve that? How do you solve that problem? Well, what's that?
Turn on custom errors.
Yeah. So the other one, the second example here is the same can be said with just URLs. In other words, if we had a site, and I know all of us have done this at some point. Where do I want to go? I want to go number 4, credits. I have the interceptor on. Let me turn it off. There we go. So here's some site, and it has URLs. Seems very benign. But the point is, if you look, what would it be? Page, right at the top of page 3. If I were to click on any of those links, well, specifically the Louisville link, the OWASP Louisville link, that is the web request that would be sent. And so you can see directly in it is the URL. How hard is it to make that browser go somewhere else now? See what I'm saying? I can change that. If I can capture that request, I can change that URL, and when that and whatever is coming back, all of a sudden is going to be a different place. And if it were some site that automatically put some sort of malware in a cookie or whatever the case may be, gotcha. Pretty easy to do. So the question becomes, how do you actually change that? How do you not have, I want to build a page and I want these links there, right? Or whatever the case may be. Well, think of the code for this page. All right. And so what you can do is on the server side, see, you're using, if you look at the get at the top of page 3, basically what this site is doing is it's using a page on the server called redirectandlog.php. So there's a server page out there, and you're sending it a parameter. You're sending it a parameter, which is the web link that you want to go to. Well, why send the web link as the parameter? How about tokenize it? How about, and you see directly below on the mitigation, what if in that PHP file, on the server, not on the client, on the server code instead, you get just a number, 1, 2, 3, 4, 5. And in the code, a simple switch statement. If it's a 1, this is the URL we're sending back. If it's a 2, because you can't now redirect things from that URL, because you can't change it. You don't know what that URL is. Does that make sense? The tokenizing, it's very valuable, very, very valuable. And you can do that in a lot of things you can do to tokenize. The very last one, this one is scary, I have to admit. And it's, to be honest, of all of these, probably the injection impacts all of you as developers. The insecure direct object reference, some degree. But the last one that I'm looking at, number 9, most definitely impacts every one of you. Because you just admitted at the beginning of this hour, you're not writing any programs whatsoever in which you don't rely on something else. The second you rely on anything, you're only as secure as whatever you're relying on. It's just that simple. All right? I think last week we might have even said it, or I don't know, all my classes and this are all running together. But did we do the whole door, right? The deadlock? Talk about that? Yeah, the glass windows, right? Right, the homes, you go through, you have these beautiful solid oak doors and deadbolts on them, and right next to it is a 1-foot wide pane glass window runs top to bottom. The deadbolt means nothing. That just keeps out the nice burglars, right? And that's the same thing in security as well. All right. So let's talk about this known vulnerabilities. We didn't go look at the CVE, did we?
We did.
We did? Oh, I got ahead of myself. That's all right. We got a few minutes. We can look at it again. Sorry, you guys.
3/4 or more injection.
Oh, absolutely. Right. So let's go take a look at... oh, good. It went with me. So if we come over to the CVE, Common Vulnerability and Exposure, this is a site that as a developer you should have bookmarked, without question. Because when you go to use something, do you know how secure it is? And you know what the issues are. So all of a sudden you are going to you're writing some sort of a web-based app, and you're going to deploy it. You get done and you go to deploy it for your client. They have a hosting service somewhere, and they say that they're giving you a, I don't know, Windows 2012 server. Let's say that's what it is. I'm just trying to make this stuff up as we go. I haven't searched for this, so I don't know what we're going to find. But coming out here and saying, okay, Windows 2012 server. And if I knew the build number, I'd put that in as well. So if you had the actual build number so you know exactly what you're using. Okay, so it looks like we have a number of issues. In fact, what do we got? Well, there's a dozen and a half in 2018 already. But you can start taking a look at stuff. So looks Adobe Type Manager font. There's a particular font in Windows 7 Service Patch 1, 8.1, Windows Server 2000 Service Patch. Well, let's just look at that real quick. So you can read a little bit about it. You can go and do some more research on it at the National Vulnerability Database. And so by going there, it'll bring up that particular, what it is. It gives you a score as far as what is the severity of it. Pretty interesting. And then you can read through the technical details, etc., etc. So if this were something, let's say out there, you were using a Windows 12 server, 2012 server, you probably have to look at the exact builds, but that font driver is not secure and creates some vulnerability. So again, you are not building the whole house. I hate to tell you that. You are trying to, you folks in here, you're trying to build roofs. Bad analogy, but it somewhat works. You 100% have to rely on all the walls and the foundation below you that you didn't do. And so you have to know where those things are. You have to know the vulnerabilities. One of the things, I think it was in here, or I went and did one of the searches. Said, give me, what is the latest search? Oh, PeopleSoft. Oh my gosh, yes, of course. A lot of companies use PeopleSoft as their sort of enterprise HR management. They do payroll, all those sort of things. Love seeing vulnerabilities in those systems. Really makes me feel good. But anyway, you could go down through it. Oh, how about, looks like we found a vulnerability in the Oracle financial services market risk component. And it has a very high severity aspect, right? Overall, 8.1 on a scale of 1 to 10, that's not good.
So you could see meltdown in here?
Probably. Meltdown is, yeah, I sort of went over briefly last week a little bit with those words, but what's that?
It's Intel?
It's actually,
Windows OS?
yeah, I'm sorry, I'm trying to get rid of my notifications here, my apologies. It's actually, it's a chip design issue, it's a computer engineering issue, and the way in which the chips were designed, and now there's billions of those chips out there, so redesigning the chip is not really the solution. So now it's like, hey, software guys, figure out how you can fix that for us. And really what it comes down to, what it is, both Spectre and Meltdown have to do with speculative memory loading. So what the operating system does and what the chips allow you to do, sorry, we're sort of off topic, but it's a good topic. It goes out and it does speculative memory reads. So you're going along executing, and at some point you're going to need some other instructions that are not yet in memory. So it reads off the disk and it brings memory in, right? It does sort of think of it like, it's not a page fault because the fault hasn't occurred yet. But it goes out and it reads and it brings memory in. Well, what it does is it actually brings in multiple things. and it allows you to overwrite into protective kernel memory. But they never thought that would be an issue, because when you actually need the memory, it will already be cached and you're going to use it back up here in user space. You won't ever get into kernel space. What happened was a couple researchers, in fact, 2 different researchers within a week of each other were able to exploit that, which I thought was phenomenal that they were able to come up with that. But they were able to find that if we loaded something in, even though before it's gone, I could still use it. I could find a way to exploit it. Now, I will say, and because I've read a lot about it, it is so narrow. And the situation and the state has to be exactly this situation, exactly this state under these conditions, that the chances of all of us or any of us being exploited by it are as close to 0 as possible without being 0. All right. So it is very, very, very small. Hey, sir. We're just finishing up. We asked about Spectre and Meltdown. So anyway, so is it an issue? Well, sure. And it's an issue because the simple fact that it can be exploited, I can tell you of at least one nation state that has a lot of people on it working now. Okay? Will it be exploited? Maybe, maybe not. But again, if it can, then it's an issue. If it's greater than 0, it's an issue. And that's where we're at right now. So the best thing folks can do is just make sure that you're updating all your devices and everything like that, because solutions are going to come not with a chip redesign. Solutions are going to come with a software solution initially.
The problem is, it's not just your phones and your computers, it's things like your routers
Absolutely.
and all kinds of things you don't think about.
Absolutely. Yep. Yep. Yes, sir.
So you said you can think of at least one nation state that's working on it. What if the NSA already knew? I mean, how do you, so your conversation is...
Yeah. If the NSA already knew about this, they're like, gosh, darn it, that's out. Because that's one less tool we will have had in our quiver, right? One less arrow.
National security is not just to exploit this in other countries.
Absolutely. Right.
It's also to protect us from other people exploiting it. And so my sense is that there's a good possibility of the NSA knew.
Well, to be honest, we all knew how those chips were designed. That wasn't a secret.
Oh, for being able to exploit it.
Yeah. Is it actually possible to do that? No one ever really knew. And we had some researchers that dove in and proved, hey, that it's possible. We all knew what pipelining and speculative execution was. That's the theory of operating systems and chip design. And I understand that concept. I would have never taken time to figure out, could I actually exploit it? So, yeah. Anyway. Anything else? I'm going to try to wrap this up because I know Eric wants to talk to me, and then I got a jet because I got a meeting. But
all right. Well, let's go ahead and end it here. That'll give you time to do that.
Sure.
We only have 5 minutes to jet at hard stop at 2.
no worries.
So let's give a warm thank you. For
Thank you. Thank you.
And we'll stop recording.
And I would tell you, if you want to hook up with me, you could do that on LinkedIn, but you learned last week I'm no longer on LinkedIn.